Just to follow up on the last video, let's have a look at how nitrogen bonds together to form N2, so the dominant gas in our atmosphere. Nitrogen has 5 valence electrons, 5 electrons in its outer shell, and of course wants to have a full shell. So how can it achieve that? It needs to gain 3, or should I say share 3 electrons in order to have a full shell. So covalent bonding, we're going to draw 2 overlapping electron shells for our nitrogens. And if we put 3 dots from this one, 1, 2, 3, we have to put 3 crosses from the other one in and then fill in the rest. So we've used up 3, and so there's another 2 to go, here and here, and 2 crosses there. And so now if we count them up, we have 1, 2, 3, 4, 5, 6, 7, 8 in this shell and 8 in this shell. And this is what's called a triple covalent bond because there are 3 pairs of electrons participating in this bond. Now it's worth mentioning that nitrogen, it is possible to form a double bond with nitrogen as well. It just means that we don't have full outer shells. And if we do that, we still end up with a valid chemical bond, but it's not as strong. So for example, I'll draw the double bond for nitrogen, which is possible, but which is not so common because it's weaker. It's weaker, so it just breaks apart more easily. Now a double bond would have to have 2 pairs, and then we just fill in the rest of the electrons. So each one has 5 electrons, so 1, 2, 3, 4, 5. And you can see it's not a completely full shell. 1, 2, 3, 4, 5, 6, 7. Not completely happy because it doesn't have a full shell. I noticed I just swapped the dots and the crosses, but that's okay. And I'll just fill these ones in as well. And what's interesting is if you can actually look this up, chemists can actually measure how much energy it takes to separate these things. And if you look them up, you'll see that the triple bond actually has an energy of 946 kilojoules per mole of nitrogen gas, whereas the double bond is a lot less. It's, I think, 418 kilojoules per mole. So it's noticeably easier to break this bond apart. It requires less energy to break this bond apart than it does to break this one.